lot line to lot line building. We would have to have wells going over the entire site in order to make this happen, going down 450 feet. Okay, so cost's important. Well, what about the environment? I think that that's why we're all here, because we care about the environment, right? Okay, so why don't we talk about greenhouse gas emissions? And the interesting thing is that this actually does have a very important impact on greenhouse gas emissions. It's about a 40% reduction in greenhouse gas emissions. That's basically due to the fact that we use Ontario data for how efficient our electricity power generation is in the province. And we use a lot of nuclear power. Over 50% of our electricity in 2011 was generated with nuclear. Something else that's really interesting, though, is that there's a lot of new generation capacity that's being added in Ontario. Since 2005, there's been 4,500 megawatts of natural gas-fired electrical generation capacity that's been added. So one of the things you have to think about a little bit, if you switch from the systems that have been discussed so far, these systems are gas-based heating systems, right? We're using condensing boilers or regular atmospheric boilers. At the end of the day, they burn gas. And what we're talking about is we're talking about using heat pumps which transfer heat with the ground exchange heat pump systems that use electricity to make that process happen. So this is a fuel switching solution. We are switching from a natural gas heating source, which has been discussed, to an electrical source for heating. Okay? This is not business as usual. This has a 49-year return on investment, simple payback. Okay? So we're talking about fuel switching. And so the only way that this is going to happen would be if it was a policy decision. You'd have to set these sorts of targets in order to make it happen, because there's no one who's going to financially do this. No one's going to step up to the plate and sign up for a 49-year simple return on investment. Right? So we may have to think a little bit about what we're doing here. When we go through and we do the analysis to get to that 40% greenhouse gas reductions, we're using a number which is based on the overall mix of where we get electricity from. Some that comes from nuclear, some that comes from hydroelectric, 2% comes from wind, some that comes from natural gas. But really, one has to ask, what are we doing here? Are we taking a natural gas burning appliance out of a condo and creating a natural gas burning electricity power plant to feed the electricity back to the condo? If we do, there still is a savings. Okay? A geothermal system is more energy efficient. It is a very efficient source of heating and cooling. But instead of it being a 40% reduction in greenhouse gases, if you were to assume that all of the electricity that's required to feed your building comes from a gas-fired electrical source, we're down to a 20% greenhouse gas reduction. So the thing that I just sort of caution here is, although it may look initially like we've hit our target, that's based on energy. We certainly haven't hit it based on cost. And it's questionable if we've hit it based on an environmental performance target such as greenhouse gas emissions. So I think the thing that I'm sort of leaving you with here is that this is a little bit more complicated. When you start pushing towards these higher performance targets, we may want to think about the approach, because what we've come up here with is call it a disintegrated design process, where the engineer is just coming up with a gizmo or a mechanical solution to get to that 25% better than current code target. What we still haven't got to is a solution where we're actually working in an integrated design fashion with the architect. We still haven't been forced to come and take a look at changing from the status quo, which is that sort of point tower, to something that's more architecturally creative such as what Michelle started off this entire presentation with. I personally would love to see our codes push us towards somewhere where we're forced to have that integrated design process take place, as opposed to just ending up with a mechanical solution.
Thank you, Lyle. As a wrap-up, I guess what I'd like to say, as a developer of the software that a lot of us use out in the field today, Brian was mentioning earlier that he was seeing Green Building Studio going towards a dashboard kind of environment where we can kind of get real-time, quick return on our information that we're putting in. We're not there yet, but I think what we're looking at is, and even brought up another point, that in the coming months, or we've actually even started, we're providing simulation solutions to customers at a no cost for you to try. And one of the comments that he made was, are we as an organization that's called Autodesk, trying to take away or remove the environmental engineers? And I think what we're seeing here right now is that there's no amount of computational machine that's going to replace good design, good engineering, good thought processes, good experimentation, and good understanding of the environmental solutions that go into our buildings and go into our environment. So I think as a software developer, the best we can provide you with is something to make you think, something to make you explore, something to give you the opportunity to explore your designs. And what I'd like to do at this time is open up the floor to questions to the panelists that we have here. And we have a mic at the table here that will kind of pass around. So if you have a specific question for a specific person, please let us know.